Okay, so I'm sort of, going to, instead of solving this algebraically, I'm going to solve this, graphically. So like a right-hand side and left-hand side are both absolute value functions. So I'm going to graph each one and then look at the intersection. 6x minus 4. So let's try to graph this. So graph of 6x minus 4, it's going to look like this. Okay, so you set the inside to 0. So 6x minus 4 equals 0. That's going to be the vertex of the graph. So this is 4 over 6, which is 2 over 3. So let's say 2 over 3 is right here. This is 2 over 3. And then the y-intercept of this function is just going to be 4, because if you make x 0, then you'll get absolute value of negative 4, which is 4. So that's 1, 2, 3, 4. That's right here. So then when you graph this, you're going to get that V shape like that. Okay, so that's the graph of the function on the left side. Now let's do the same thing for the right hand side. So that's 6 absolute value of 6x minus 3. So set that to 0. So that was actually, it was, let me see the original question you asked. I think it's 6x plus 3. So I think I copied that wrong. Sorry, that was plus 3 right here. Okay, so 6x plus 3 equals 0, then x equals a negative a half. And negative a half is right here. Let's say this is negative a half. And then it's going to pass through positive 3, because if you place the 0 right here, then the y-intercept is 3, which is right here, that point. So then it's going to pass through that point and have that V shape right here. You see, we have an intersection point, which is right here, right? So from this point, I'm going to look if the function on the left must be on the upper, so like on the top, because if it's on the top, then it will be bigger than the one on the right hand side. So the right hand side is the blue graph and the left hand side is the black graph. So I want the black graph to be above the blue graph. Okay, and where does that happen? So that's what I need to see. So this is, I need to find the intersection. So I can find the intersection by doing this. So I'm going to set these functions to each other, but the intersection, so if you look at the intersection must be 6x minus 4 equal to opposite of this function here. And the reason is that because the black graph has a negative slope and the blue graph has a positive slope at that point. So that's why I need to change the sign of the black graph to negative. So I set them each other. 6x minus 4 equals negative 6x negative 3, then add 6 to both sides. So this will be 12x equal, add 4 to both sides. This is positive 1. So x will equals 1 over 12. So this point right here is 1 over 12. Now, if you look at the entire left, the left on the left of 1 over 12, then you will see that the black graph, which is 6x minus 4, is above the blue graph. And that's what I like, because we want to see all the values of absolute value of 6x minus 4 are bigger than all the values of absolute value of 6x plus 3. So therefore, the solution will be, because this is negative infinity, it will be all the numbers from negative infinity to 1 over 12. And because you have equality there as well, so this will be a bracket here. Okay, so that will be the solution. I prefer doing it graphically, because algebraically this can get a little bit complicated. So all we have to do is find the intersection and then look on which part of the intersection, left or right, the right hand side is above the left hand side. So of course, depending on this, because this is bigger than, so then the left hand side must be above the right hand side. So that's basically it.